Hi, this is Tom Brower from the Hydrologic Engineering Center. In this video, I'm going to go over some advanced calibration techniques that were used in a 60-year continuous simulation of the Russian River in California. This is the Basin Map as configured in HEC-HMS. As you can see, there are 6 calibration locations. This study weighed the competing interests of water supply in the Coyote Valley Dam Reservoir versus flood risk downstream. It was important that both volumes and peak flows were well represented by the model. Calibration should always proceed from upstream to downstream. In this case, we are starting with our most upstream subbasin, East Fork Russian 20. If we run our 60-year simulation, the result is a 60-year runoff hydrograph. How do we calibrate a 60-year hydrograph? In this case, we use runoff signatures to make graphical inspections easier. Runoff signatures are response patterns. Examples include annual runoff, seasonal runoff, a flow duration curve, low flow flow frequency curve, high flow flow frequency curve, and the runoff hydrograph. Of these, the runoff hydrograph is the most familiar, but from the runoff hydrograph we can derive an annual maximum flow series and a monthly volume distribution. The annual maximum flow frequency curve was evaluated to characterize flood risk. If we were going to do a single water year calibration, we would focus on individual hydrograph peaks. Peak flows are sensitive to the infiltration rate in the soil loss model. For the period of record, we adjusted these parameters while graphically inspecting the flow frequency curve. The focus of calibration was overall correlation between computed and observed flow frequency curves with emphasis on low probability events, since the study was focused on flood risk. Finally, we zoomed in on the runoff hydrograph to calibrate the recession limb of hydrographs and baseflow recession curves. All of the baseflow methods in HEC-HMS require a graphical fit to calibrate coefficients. The calibration proceeded from upstream to downstream. For each calibration location, the monthly volume, annual maximum flow, and runoff hydrograph calibrations were performed. The model was considered calibrated once the calibration at the final modeling location was complete. We used summary statistics throughout the calibration process to quantify modeling performance. The calibrated model performed very good for all statistics at all locations based on the ranges defined. This concludes the presentation on advanced calibration techniques. For more resources on HEC-HMS, check out the HEC-HMS documentation website.